Hello, welcome to this taster lecture for our geography degrees at the University of Leicester. The title of my presentation is Are You Cooking the Planet? And I hope by the end of this that you're going to be able to answer that question. So just to get us started thinking about my topic, I'm asking you to have a quick look at those photographs and see if you can come up with any way in which they might be connected. So on the left-hand side, we've got a picture of tropical rainforest and an orangutan. In the middle panel, we've got land clearance happening. Bit of a clue in the bottom middle picture. And then top right is some products that you might buy in the supermarket, and then a picture of extreme rainfall resulting in flooding in the UK. So I wonder how many of you have been able to make the connection. The clue very much is in that middle bottom picture. So here we are. What I'm going to be talking about is carbon dense ecosystems. So tropical forests and one particular type of tropical forest, which is peat swamp forest. Thinking about how those forests, particularly in Southeast Asia, are being cleared. And this is leading to high greenhouse gas emissions into the atmosphere. Then thinking about what's driving that change, that land use change. And to a large extent, this is being driven by conversion of forest into plantations, particularly to produce palm oil. And then finally, we'll kind of make the link to high greenhouse gas emissions and our changing climate. So, are you cooking the planet? If you are, the reason for that might be what you can see in your shopping trolley. Are you cooking the planet is a question which is asking questions about big environmental issues. And what I want to really emphasize in this short taster lecture is geographical approaches. So we're going to be thinking about approaches that come from the physical geography, the science side of geography, about the global carbon cycle, about technologies that we can use, such as remote sensing, to understand and uncover change, and then thinking about the carbon consequences of those changes. But it also feeds into questions about global trade, for example, globalization, the global demand for cheap vegetable oils, so the economics of geography, the politics of geography. And then when we come on to think about solutions, we're maybe thinking about ethical consumption, sustainable management, questions which also feed into the social science side of geography. I want to move on now to think about the impact that human actions are having on our atmosphere, as this will set the scene for where we go on to discuss tropical deforestation in a minute. So this is the record of atmospheric carbon dioxide concentration at the Mauna Loa Observatory, which is located in Hawaii. And this provides us with a record of our atmosphere, the amount of CO2 that's present in our atmosphere, which we believe is a key driver of our changing climate. And you can see that since the observatory began its records, in 1957, that the atmospheric CO2 concentration has steadily increased over that time. And one of the contributors to that increasing carbon in the atmosphere is the role played by land use change. And some of the greatest land use change is happening in the tropical regions of the world. So from this work we can see that the tropical regions of the world are either acting as a carbon sink, the downward facing green arrows, which implies that our tropical forests are sequestering carbon from the atmosphere and storing it over the long term in forest growth. But we can also see that in some tropical regions of the world, particularly Southeast Asia, that carbon sink is being overridden by a large carbon source back to the atmosphere. And this is an indicator of the impact of deforestation, land use change. And you can see here from this infographic that tropical Africa is a strong net carbon sink. Tropical America is a weak net sink of carbon, but tropical Asia is a very strong net source of carbon to the atmosphere. So we need to ask the question, why are Southeast Asian forests such a strong source of carbon? And it's all to do with land use change. Southeast Asia has a diversity of forest types, evergreen rainforest, the kind of archetypal rainforest vegetation, everything from that through to hill forests, coastal mangrove forests, and also peat and freshwater swamp forests, which I'm going to say a bit more about. If we look at the drivers of forest loss in Southeast Asia over the last few decades, then from this map you can see that there are some very strong colours there, blue colours and red colours. And if you follow those through in the legend, you'll see this is down to logging, which is blue, and also conversion of land to oil palm plantations, shown in red. And in Southeast Asia, there has been a very rapid conversion of forests to plantations over the last 20 years. And that has happened particularly on the peatland areas. So we have these coastal lowlands of Southeast Asia, which are, to the most part, quite waterlogged, and rather than decomposition proceeding in the normal way, a lot of that forest biomass accumulates as peat because of waterlogging at the soil surface. But those peatlands and peat swamp forest, which is the natural vegetation, have been increasingly converted to plantations over the last few decades. So we have to ask the question, why does it matter that the peat swamp forests have been the focus of such rapid land use change? And what has that got to do with those items that we saw in the shopping trolley? So I now want to move on to focus on the peat swamps and the carbon impact of land use change driven by those large-scale plantation conversions. And I also want to think a little bit about why it is that the peatlands have been the focus for such rapid land use change. Well, you might be surprised to learn that there are peatlands in the tropics, because when we talk about peatland ecosystems, which I'm sure you've studied as part of your geography syllabus, you tend to think that they're mostly located in the cool, wet northern regions of the world. But you can see that there are extensive peatlands also in the tropics, particularly in Southeast Asia, but also in the basin of the River Amazon and in the Congo Basin in Africa as well. And peatlands are intriguing ecosystems. We call them peatlands, but in fact they're largely made up of water. So they are part land, but part water. And it's that waterlogging that creates the anoxic conditions that prevents the breakdown of much of the organic matter. So the organic matter, in the case of tropical peatlands, being produced by that forest biomass, it's accumulating. Most of it doesn't decompose, and so you get the accumulation of really deep peat deposits over thousands of years. And in the tropics, some of those deposits are 10, 15, even 20 meters thick. And that accumulation of organic material, and remember that that's not just organic material, it's carbon, because vegetation is about 50% carbon by dry weight, and hence peat is also 50% carbon by dry weight. that accumulation of peat and of carbon will continue as long as the water tables are at or close to the peat surface throughout the year. But anything that happens to promote drainage, so lowering of the peat water table, will lead to oxidation. So as soon as oxygen can enter into the peat profile, bacteria, fungi will act to very quickly start to decompose that organic material, and that will lead to high emissions of CO2 to the atmosphere. And also, particularly in Southeast Asia, this may be associated with an increased risk of fire, and that's a further source of greenhouse gas emissions to the atmosphere. All agricultural land uses on peatland require drainage, and I've already told you that there's been very extensive conversion to plantations. So if oil palm is being grown, then the water tables need to be at least 60 to 80, often more than that, centimetres below the peat surface. Another big plantation user in business in Southeast Asia is for pulpwood, so for paper production. And again, water tables need to be at least 70 centimetres below the peat surface. In practice, it's often the case that water tables are considerably lower than that, maybe even up to 1 metre or 1.5 metres. So that means you're exposing up to 70 or maybe 100 centimetres of peat at the peat surface to aerobic decomposition. And this is happening at really large scale. So every one of those drainage ditches there in the peat is 800 metres long, 800 metres extending to the horizon. So this is really happening at a large scale, and hence the scale of the CO2 emissions as well, also very significant. So we've seen that oil palm plantation establishment has grown rapidly in Southeast Asia over the last 2 decades, but of course that's been driven by global demand for a cheap vegetable oil, and at the present time Indonesia and Malaysia are meeting 85% of that global palm oil demand. Where does palm oil end up? Well, it ends up in your supermarket trolley and those products that you can see in the picture on the left-hand side, but it also is ending up in biodiesel as well. So a so-called green fuel is also driving the demand for palm oil. And the conversion of plantations is happening apace, particularly on the peatlands. So palm oil accounts for about 35% of the world's vegetable oil market. And if you look at the panel on the right, you can see why that might be, because the yield per hectare per year massively outstrips all of the other sources of vegetable oil, whether that's soybean or sunflower or rapeseed. So it's a highly efficient crop for producing vegetable oil. And it makes up a lot of the land uses on peat in Southeast Asia. So between smallholder farms, many of which are also growing oil palm, and the big industrial plantations, about 50% of all the peatlands in Southeast Asia have been converted. So the forest has been lost and they've been drained, and they're a strong source of carbon dioxide to the atmosphere. And just to give you some idea of the scale and rate of change, this is the Rajang Delta in Sarawak, and it is a peatland area. Low-lying coastal peat swamps have been drained over the last 15 years or so and converted to oil palm plantations. So in the top panel, you have the situation in 2004 with plantations developed on peatland soils. Then we go to 2009, and then the final big panel is 2014, by which point you can see that nearly all of the peat swamp forest has been cleared. The land has been converted to plantations, only a very small amount of the original forest still remains. And as a result, tropical peatlands, although they don't make up such a big area, a portion of the total peatland amount by area, which is the figure A, if you look at figure C, they make up a very large proportion of all the world's emissions of greenhouse gases from drained organic soils. I also briefly mentioned fire earlier, and this has become an increasing problem as well, because fire is often used as part of the land use change clearance activities. So fire is used to clear forest debris, and it may also be used by smallholder farmers as well as part of their land management activities. And once fire gets established in areas with peatland, it can smoulder in the ground over long periods of time, and again releasing very high amounts of greenhouse gases into the atmosphere. The fires in 97-98 were so extreme that they could actually be picked up in that global CO2 record that we mentioned earlier. So there's clearly a lot of knowledge about what forest clearance, forest loss and plantation development, particularly on peat soils, is doing in terms of our global climate. So you might ask the question, why does this type of land use still continue? Well, there are various reasons. In Sarawak, for example, its mountainous interior means that there is very little in the way of low, flat landscapes that can be exploited for agriculture. So the peatlands have been cleared as in part as a response to a shortage of land suitable for agricultural use. Economics. Companies may subsidise the establishment of their plantations by selling the timber that they can derive from the forest. And it was often the case that only peat swamp forests, up until fairly recently, offered the high quality timber that could be exploited in conversion to plantations. So as an economic incentive to clear the land. There's also clearly a global driver. There's a demand for cheap vegetable oil, and that's being driven by you and by me. And there are livelihoods as well. So there's a growing smallholder farming sector, particularly in Indonesia, and oil palm is one of their chosen crops. It provides a good economic return for smallholder farmers. And the demand for palm oil is growing and is likely to continue to grow. And it, as we've already seen, it's a high yielding crop. It's relatively cheap to produce. There's a high demand for vegetable oils going into food products, but also a whole range of other products as well, even cosmetics. A growing demand for renewable energy sources. And maybe what we see happening in Southeast Asia today, we could see happening in the future on those peatlands in South America and Central Africa. So what's being done about this? Well, there are various national and international initiatives to improve practices. You may well have seen the RSPO certified sustainable palm oil logo on some products that you buy. So that's one thing that you could certainly look out for, is look to see whether you've got palm oil on the list of ingredients of products that you're currently buying, and if so, do they conform to the RSPO standard. Of course, even for plantations which are being managed according to that RSPO standard, if those plantations are on peatland, then they're still going to be emitting to the atmosphere. So there is little that RSPO can do to mitigate those emissions, other than to require that plantation owners maintain as high a water table in their plantations as is possible. Some of the companies that are producing palm oil have committed recently to various policies such as zero burn, zero deforestation, and no more planting on peatland. So they're still maintaining existing plantations on peatland, but they've committed to no more planting on those soils. There are various research programs going on by various companies, but also, for example, by the Malaysian Palm Oil Board, which are looking into ways that we can mitigate some of those greenhouse gas emissions, so try to minimise the emissions. And that's all, again, related to water management, but also to fertiliser application as well. And the Indonesian government has committed to a moratorium on further plantation development on peatland, so no further development at the current time. So I hope you've seen the ways in which geography can help us approach a big environmental issue. We've linked the science of geography around the global carbon cycle, land cover change and carbon consequences for our climate, and those link across to global trade patterns and also to initiatives to drive forward more ethical consumption patterns. I hope you've been able to follow through the logic of the mini lecture, from thinking about our tropical forests as carbon-dense ecosystems, linking that to deforestation and to drainage of peat swamp forests and the emissions of greenhouse gases into our atmosphere, all driven by the high demand for a vegetable oil with many uses, and to the global consequences of high greenhouse gas emissions, which are changing our global climate. So take one more look at your trolley and think about going to have a look at the products that you use regularly in your household to see whether your consumption is cooking the planet. And if you're interested in finding out more about tropical peatlands in particular, then you can go to this Geography Association Teacher's Guide, which will give you more information, more detail on some of the research and some of the teaching that we do in geography at the University of Leicester. Thank you.